Alright, hello and welcome back, everyone. Today we're going to be talking about problem number 5 from this Physics C Mechanics multiple choice test with 35 questions. I'm attempting to get through all of them. So, let's read this problem. Two identical boxes are transported to an orbiting space station. The astronauts know one box is filled with a light sample of ants for some type of testing, and the other is filled with heavy tools for repairs on the spacecraft. How can they tell, without opening the boxes, which box holds the tools? So, the most important part of this problem, if you miss this, you have zero chance of getting it right. Actually, that's not true. You can always guess. But a friend of mine was looking at this problem, didn't catch the fact that they're orbiting Earth on a space station, and just figured you could just weigh the boxes. But that's ignoring the very essential part of this problem, that there's no gravity when you're orbiting in space. If you've seen pictures, videos of astronauts weightless in their space station floating around, that's very essential to this problem. So a lot of these different methods which would work here on Earth of figuring out which box has the heavy tools and which box has the light ants, which would work on Earth, are not going to work when you're on a space station with no gravity. So let's read through the answers and think about this. So let's talk about some concepts first. So Newton's second law can be written as force equals mass times acceleration. Also, if you divide by m, as acceleration equals force over mass. Very important law in physics. Sorry, I don't know if you can read this. It's a little bit small. So the acceleration here in space, there's no gravity, there's no g to make objects accelerate downwards. As we talked about, that's essential. So if we're weighing each box on a spring scale, what do spring scales measure? It's like when you get on like a scale reader in the bathroom, a spring scale though, not an electronic one. It's going to measure the amount of force exerted downwards on it. But that force is coming from mass times gravity, your weight, your mg. This is often written force equals mg when acceleration is gravity. When that is, there's like on Earth, there's a huge, massive, powerful gravitational force pulling us downward. So if there isn't this gravity, it's not going to be able to properly weigh us because there's going to be no force pushing down on the scale. That eliminates A. So if we look at B, shake each box. What does shaking mean? Shaking is like you're going back and forth with something. So it's kind of a measure of how resistant like the mass is to movement, which is inertia. So shaking each box. This takes into account inertia, which is mr squared. Moment of inertia. So let's come back to B after a little bit. Pushing each box. Again, it's talking about gravity. It's saying like there's more here. Let's make a quick free body diagram, assuming we're on Earth. So this is a box. If we're pushing it forwards, there's a force going forwards. This is the push force. If we're assuming we're on Earth for the sake of this diagram, there's mg. There's the normal force. If you're pushing something forwards, I guess there's friction also, but let's just forget about that for now. If you're pushing something forwards, you're not just pushing it's not just the inertia that you're pushing. You're kind of fighting this gravitational force pulling downwards. But if you're pushing each box in space, if you think about it, like the box will be floating, and you extend your arm and you push it, they're going to be moving at the same speed. There's going to be no difference. Because there's not going to be gravity in this case. So let's get rid of this one. That's not going to work. Place each box on opposite sides of a balance. Similar to a scale, We know there's no gravity in space. Not gonna work. Toss each box straight up. This is my favorite answer. Like, come on, you're in space. If you toss something straight up, it's gonna keep going because there's no other force that's acting on it. There's no gravity pulling it down. If you toss something up in space, it's gonna keep going forever. No, that's crazy. That's like their one throwaway answer. So that leaves us, by way of elimination, just by way of we know that there's no gravity in space, we're left with B, shaking each box, because that doesn't deal with gravity, that deals with moment of inertia, which is something that we can calculate in space that is not dependent upon gravity. So let me know if you have any questions below about the concepts here, how I eliminated options, how I discussed this. Thanks for watching, and check back in for my next video.